Okay, the terms increasing, decreasing, and constant are actually very big ideas that come up in some very critical places in calculus. You will spend a lot of time analyzing things when they're increasing, decreasing, and constant. So it helps to really get an idea as to what all this stuff means. So in a very simple sense, as x gets bigger, when it's increasing, y also gets bigger. Okay, so let me kind of relate this to one of our parent graphs. Y equals x squared. Okay. In this picture, the part that's increasing, see here you've got this piece as the x's get bigger, the y values are going down, but on this half, as the x gets bigger, the y values are going up. So this is an illustration of increasing when we're looking at the interval from 0 to infinity. Okay. And similarly, so I kind of illustrated that in the example, um, decreasing means as x gets larger, the y values themselves get smaller. So going back to this same picture that we talked about, um, we're looking at a piece of, let's see, so as the x's get larger, the y values themselves get smaller. So in this graph, in the parent graph y equals x squared, it's decreasing from negative infinity up to 0. Okay. Now constant simply means that as x increases, y's stay the same. That there is no improvement or increase in y. And so I'm going to illustrate this with the piecewise graph. I'm just going to manufacture some points here. So it's going to be closed up till 0, and then we'll have this straight interval over to 1, and then it'll kick up again. So in that particular graph, the piece that's constant is when we're looking at just this flat piece right here, that interval right there. And so the constant piece would go from 0 to 2. Okay. Now, each textbook is going to define this differently, so you want to stop and kind of look at what your textbook says. Most textbooks that I've seen define increasing, decreasing, and constant through open intervals. But it is possible you might see a textbook that would take the same situation and in this case would close it. So I would watch for whatever definition the book says in it. Okay, so we're going to illustrate these three ideas through just some transformations of parent graphs. It's always good practice. So I'm going to sketch in this. I'm looking at negative x cubed. So in the x cubed function, I know it goes through 0, 0. Normally, as x goes to 1, the y would go to 1, but in this case it goes to negative 1. And when x goes to negative 1, y goes to negative 1. Sorry, positive 1, because we're dealing with negative x cubed. And then we're going to go to when x is 2, we get negative 8 here. And when x is negative 2, we get positive 8 here. Okay, so we're looking at this piece. Okay, so in that function, where do we see an example of increasing y values? And that would be starting at nowhere. The entire time, the y values are getting smaller. I mean, something interesting happens at 0, but we are increasing nowhere, and then we are decreasing the entire interval from negative infinity up to infinity, and then there's no place where this thing is constant. Okay. All right, then we're going to go number 2. Number 2, we're looking at, again, a transformation of the rational graph of 1 over x. If you remember, the rational has asymptotes. I'm going to sketch those in there. And the negatives, normally the rational goes from the first and the third. This time it's going to go in the second and the fourth. Okay. And we're looking for places where the y values are increasing. So as from this half of the graph, as x gets larger and larger, the y values are actually going up. So I know it's increasing at least from negative infinity up till 0. Okay. And there is some sort of jump at 0. Now after 0, what happens? The y values start almost at negative infinity, and they keep getting larger and larger till they approach here. So they're actually getting larger after 0 as well, which means nowhere is it decreasing and nowhere is it constant. Okay. Okay, so at number 3 again, we're looking at a transformed square root function. So this still has a critical point, still goes through 0, 0. Instead of going through 1, 1, it's going to go through negative 1, 1, and then go through negative 4, 2, and negative 9, 3. Sorry, that's a close point there. And what are the y values doing the whole time? The y values are actually getting smaller the whole time. So it is decreasing from negative infinity up till 0, in which case it stops at 0. So there's no place where it's increasing and no place where it's constant. In stark contrast, number 4 here, we have a flat horizontal line at 4, which means we're looking at constant, and it's constant the entire time, which means it's not increasing or not decreasing anywhere. And last but not least, we're going to do some piecewise, so kind of get some combinations of functions and hopefully see some different things. So the first task would be to actually sketch a picture of this. So here we got from 0 seems to be a critical point. So at 0, for the top part, we have an open circle at 2, and then it's a flat line at values less than 2. Here, let's see, so if I plug a 0 and evaluate it at 0, I get 1 squared, so I get closed point at 1. And let's see, if I go over 1, I get 4. If I go over 2, I get 9. So it looks like those 2 points are crossing. They're actually not. Alright, so what's going on from negative infinity up to 0? That's a constant. And then at 0 on, it is increasing. And it is decreasing nowhere. Okay. Alright, so this last example, again, piecewise, we're looking at negative 1's are transition. So at negative 1, we got square root of 3 minus a negative 1. Write that out so you can see what I'm talking about out loud here. So that would be square root of 4. So at negative 1, we have a y value of 2. That's an open circle. Let's see. And it's going to look like a sort of a square root, but instead of going towards the positive x, it's going to go out towards the negative x, kind of like example 4. So we just got to think about where's another good clean point. Let's see, so if I got 4, next one would be 9. So negative 6. So at negative 6, we're at 3. So it looks about like that. And then at negative 1, we get sort of a close point there. This is from the bottom equation. And then at 0, it goes through 0, and then it goes up. So it looks like a V. So we get like this sort of check mark looking graph. Okay. So what's going on? I see from negative infinity up till -1, it's decreasing. And it's also decreasing as it goes from -1 to 0. There is a jump there. It's not a connected point. So we do want to indicate that there is something interesting going on at -1. There's no constant in the picture. And then it's increasing after 0. So 0 out to infinity. It's actually increasing the whole time.